Fruit Ninja came out 15 years ago, and we've been slicing virtual apples with our dirty thumbs ever since. But playing a game about knives without using an actual knife felt like a missed opportunity. Therefore, I needed computer vision to turn my camera into a motion sensor. So naturally, I went to YouTube for help and immediately questioned my life choices. I started with OpenCV and MediaPipe. The goal? Track a razor-sharp 8-inch kitchen knife in real time. But if the camera tracking lags or teleports for even a microsecond, I'm going to chop off my micro P. I ran the test script and boom, hand tracking worked. For a split second I genuinely felt like Doctor Strange. But hand tracking wasn't enough. I needed the computer to track the knife itself. I could have used color tracking or traditional computer vision techniques like edge detection, but shiny metal creates inconsistent features that are unreliable under different lighting. Therefore, I decided to train my own custom AI model. I pulled up Ultralytics YOLO11 and installed it, but my laptop decided to take a full break, turning a 10-second command into a test of human patience. Once it finally loaded, the default AI model happily detected random objects around my room, but when I held up the actual knife, the AI looked at it and saw absolutely nothing. Therefore, if the AI didn't know what a knife was, I had to teach it. I recorded a video waving the knife around, extracted over 600 individual frames and prepared for neural network bootcamp. But manually drawing boxes around 600 photos sounded like torture. So I used the AI-assisted labeling tools in Roboflow to speed up the process. I went through approval duty, rejecting blurry images, fixing bad annotations, and keeping only the sharpest frames. Because if I fed the model bad data, the AI would hallucinate knives or miss them completely, which we do not want. I kicked off local training and waited 2 long hours. The result? A 94.6% precision score. On paper, it was a masterpiece. But in reality, it tracked the knife, but it also produced false positives, detecting random objects in the background as my knife. Therefore, I increased the confidence threshold, forcing the model to only accept higher confidence knife detections, which resulted in cleaner and more workable tracking. I flipped the inverted camera axis with 1 line of code and the tracking engine was officially complete. Now I needed a game. I jumped into Unity, speedran a Fruit Ninja prototype with custom spawners and slicing physics, and tested it with a mouse. But mouse controls are not what we are going with. To bridge my Python AI to Unity, I built a UDP socket to stream knife coordinates from Python into Unity in real time. It worked, but there was a massive catch. Computer vision tracking is inherently jittery. The cursor was vibrating violently, making precise slicing almost impossible. Therefore, I implemented LERP mathematical smoothing. It acts like a low-pass filter, making the blade float as smooth as technically possible. And just like that, Fruit Ninja with real chef's knife was alive. Low enough latency that it actually felt playable, no phantom cuts, and most importantly, my monitor survived. If you want to see what insane project I try to build next, hit subscribe and please do not try this at home.